Have you ever looked up at the night sky and wondered, what if one of those tiny specks of light wasn't a star, but an asteroid heading our way? It sounds like something straight out of a Hollywood blockbuster, right? A giant space rock hurtling towards Earth, threatening our very existence. But here's the thing, it's not just science fiction. Asteroid impacts are a real, albeit rare, natural hazard. So, the big question is, are we actually ready for one? Today, we're diving deep into the truth about planetary defense. First off, let's get some perspective. Tiny meteoroids hit Earth's atmosphere all the time, burning up as shooting stars. It's the big ones we worry about, the kind that could cause widespread damage. The most famous example is the asteroid that wiped out the dinosaurs 66 million years ago. It was about 10 kilometers wide. The good news? An impact of that scale is incredibly rare, happening maybe once every 100 million years. But what about smaller, city-killer-sized asteroids? Those are more frequent, and that's where our focus is. So, step 1 in planetary defense is finding them. You can't stop what you can't see, right? This is where NASA and other space agencies around the world come in. They run programs dedicated to scanning the skies for near-Earth objects, or NEOs. Telescopes on the ground and in space, like the Pan-STARRS in Hawaii and the Catalina Sky Survey, are constantly on the lookout. They've already cataloged over 90% of the truly massive, civilization-ending asteroids. And thankfully, none of them are on a collision course with Earth for the foreseeable future. That's a huge relief. But what about the ones we haven't found yet? There are still thousands of smaller, but still dangerous, asteroids out there that are harder to spot. This is why projects like the upcoming NEO Surveyor are so critical. It's a space-based infrared telescope specifically designed to hunt down these elusive space rocks. By detecting the heat they emit, it can find them much more effectively than visible light telescopes. The goal is to create a comprehensive map of our cosmic neighborhood, so there are no surprises. Okay, so let's say we find one. An asteroid is on a collision course with Earth, and we have a few years' notice. What do? Do we send Bruce Willis and a team of oil drillers? Well, not exactly. Scientists have been working on some seriously cool, and much more practical, methods. The leading contender is something called a kinetic impactor. This is basically a high-speed game of cosmic billiards. We'd send a spacecraft to deliberately crash into the asteroid. The goal isn't to blow it to smithereens, but to give it a tiny nudge. Over several years, that tiny nudge changes its path just enough to miss Earth entirely. And we know this works. Remember NASA's DART mission? That was the Double Asteroid Redirection Test. In 2022, they slammed a spacecraft into a small asteroid moonlet named Dimorphos, which was millions of miles away. It was a spectacular success. The impact changed Dimorphos's orbit around its larger companion asteroid, Deimos, by a whopping 32 minutes, way more than the few minutes scientists had hoped for. This was the world's first ever planetary defense test, and it proved that we have a viable technique to defend our planet. It was a historic moment for humanity. But the kinetic impactor isn't our only tool. What if we need a stronger push, or the asteroid is a different type, like a loose pile of rubble instead of a solid rock? Another idea is the gravity tractor. This involves parking a heavy spacecraft near the asteroid. The spacecraft's tiny gravitational pull, over a long period, would slowly tow the asteroid onto a new, safer trajectory. It's a much more gentle and precise method, like a cosmic tugboat guiding a massive ship. It takes longer, but it offers a lot of control. Then there are the more explosive options. While nuking an asteroid like in the movies is generally seen as a last resort due to the risk of creating multiple radioactive fragments, a variation of this idea is being considered. It's called a standoff nuclear detonation. Instead of a direct hit, a nuclear device would be detonated at a distance from the asteroid. The intense radiation would vaporize a layer of the asteroid's surface, creating a powerful jet of material that would push the asteroid off course. This could be a powerful tool for deflecting very large asteroids, or if we have very little warning time. Of course, all of this requires international cooperation. An asteroid threat isn't one country's problem. It's a global challenge. That's why organizations like the International Asteroid Warning Network and the Space Mission Planning Advisory Group exists. They bring together scientists, engineers, and space agencies from all over the world to share data, coordinate observations, and develop response plans. If a threat is detected, these groups would work together to confirm the trajectory and decide on the best course of action. It's a great example of how we can unite to solve big problems. Now, let's talk about what happens if we don't have enough warning, or if a smaller, undetected asteroid slips through. This is where civil defense and emergency preparedness come in. Think of it like preparing for a hurricane or an earthquake. If an impact is imminent in a specific region, authorities would issue warnings, coordinate evacuations, and prepare for the aftermath. The impact of a small asteroid over a populated area could be similar to a large explosion, causing significant damage. By having clear communication and emergency plans in place, we can save lives and mitigate the damage. For example, the Chelyabinsk meteor event in 2013 in Russia was a wake-up call. A roughly 20-meter asteroid entered the atmosphere without any warning. It exploded in the air with the force of about 30 Hiroshima bombs. The shockwave shattered windows and injured over 1,500 people, mostly from flying glass. It showed us that even relatively small objects can cause significant disruption. But it also taught us valuable lessons about what to expect and how to prepare our communities for such an event. The key takeaway was the importance of duck and cover and staying away from windows during an air. So, back to our original question. Are we ready? The answer is a qualified yes. We're more ready than we've ever been in human history. We have the technology to find most threatening asteroids. We've successfully tested a method to deflect them. And we have international frameworks for cooperation and response. We're not sitting ducks. We're actively working to protect our planet. However, the work is far from over. We need to continue funding and supporting survey programs like the NEO Surveyor to find 100% of the potential threats. We need to further develop and test different deflection technologies to have a versatile toolkit ready for any type of asteroid. And we need to strengthen our global communication and emergency response plans. Planetary defense is like an insurance policy for Earth. You hope you never have to use it, but you need to keep it active. The threat of an asteroid impact can feel scary, but it's also a source of inspiration. It reminds us that we all share this one fragile planet, floating in the vastness of space. And when we face a common threat, we have the ability to come together, using our intelligence, creativity, and collaborative spirit to ensure a safe future. We are the first generation in history that can do something about this. We are the guardians of our planet. The dinosaurs didn't have a space program, but we do. And that makes all the difference. Thanks for watching. It's a fascinating topic, isn't it? If you enjoyed this deep dive into planetary defense, don't forget to hit that like button and subscribe for more content about science and space. Let me know your thoughts in the comments below. Stay curious and keep looking up.